We would like to acknowledge the Kaurna people, the traditional custodians of the land on which this house is built. We pay our deep respects to elders both past, present and emerging. Hi, my name is Clive and I'm an engineer. Stephanie, my wife, is an art teacher. When planning our renovation, this led to a lot of hopefully creative tension between functionality and the look and feel of the house. Overall, I think we've achieved a great balance. I propose to give you some background and talk about the driving principles behind the major decisions. I will then talk about the passive house design and our active Trombe wall, which is basically a solar air heater. I will then talk about some of the building materials decisions. We have been living in the house since 1982, and although it had renovations in the first decade of ownership, these were no longer suitable. We needed to spend considerable money on the house anyway, and after some analysis we decided that it was worth spending more on the renovation to get lower energy use while achieving a higher level of comfort. At our age, we feel the cold more than we used to. Most of the appliances were at the end of their life, including the heating and cooling. Other issues were that we had upgraded the wet areas 30 odd years ago, but they needed doing again. The house was poorly oriented and there wasn't any daytime room with a northern exposure. The kitchen dining area was too small and it was now tired and it didn't have a view of the garden. I'd always been interested in energy efficient housing and we discussed the possibility of getting a block and designing a new house. However, a lot of good work is being done on new houses and I felt that I could contribute more using my air conditioning background by experimenting with an energy efficient renovation, a much harder task. Since most appliances needed replacement, we could change to an all-electric house at negligible additional cost, particularly given that the roof has a relatively low amount of shading, giving good solar photovoltaic performance. As the house was built shortly after the First World War, we wanted to retain the look and feel of the original house as much as possible. We wanted to reuse existing materials where possible to minimise additional embodied energy and to acknowledge the original house. I wanted to use my knowledge and experience to build an experimental energy efficient renovation. In order to remain living in the house, we decided on staged construction to keep the old bathroom until the new was ready and create a temporary kitchen. I decided that I would own a build because I felt it was unlikely a builder would be comfortable being as experimental as I wanted to be. Because of my previous experience in the building industry, I felt capable of doing this, although it was a big challenge. The renovation was designed using version 8 of the Passive House Planning Package. This aims to produce houses with a very low energy use. As is usual with the standard, we've incorporated a heat recovery ventilator so that we get a controlled amount of fresh air all the time. However, one problem we have is that in winter evenings, air pollution in Adelaide is dominated by wood fire heaters. We live in an older area and all the original houses were built with a wood fire in each room and a lot of people still use them. Because the air intake is at approximately 5 metres above the ground, it is taking air from chimney height, and on a still day the smoky air sits at that level and I'm having to change the air intake height to get less polluted air. We've not completed all the changes to the house, particularly in the older part of the house, but it is already performing very well. The Passive House standard is not prescriptive, but it's not possible to achieve it without consideration of insulation, air tightness and solar gain. I had previously built what I call an active Trombe wall, basically a solar air heater. I've integrated this into the air conditioning design to minimise heating energy use. Windows cost far more than the apparent purchase price. This cost is reflected in energy, comfort or lack thereof, and the cost of window treatments. So it's natural that all the windows are double or triple glazed with low E glass. In addition, they either have blinds, curtains, or both, except for the bathrooms and the original feature light adjacent the front door. Because we were having continuous mechanical ventilation and air conditioning, I made the decision that all the new windows would be fixed glazing, which is very much cheaper and has less air leakage. One early design decision was for 200mm thick structurally insulated roof panels. The advantages were the ability to span the renovated area without supports. However, the decision to stick with a flat ceiling nullified this advantage, and as the cost was high, I wouldn't use them again in the same application, although there are cases where they are the best solution. I wanted to super insulate the house, including the 4 retained cavity brick rooms at the front. I decided that the best solution was 100mm of rendered styrene foam insulation, which was also used on the new walls. I know some people feel the environmental negatives of styrene foam make it a poor choice. However, my belief is that if it's to be there for 50 years and is going to save a large amount of energy, it is justified.